Morning to all of you. Today we'll go for the topic that is cloud programming, environment and application. So what is actually programming is done in the cloud, and which are the different types of environment and what are the application. So features of cloud and grid platform. So cloud capabilities and platform features. In that, traditional feature common to the grid and cloud. In that, we have to study what is workflow, what is data transport, security, privacy and availability. Then data features and databases. In that, program libraries, blobs and drives. Then your DPFS, SQL and relational database, tables and NoSQL, non-relational database, queuing service, programming and runtime support. In that, workers and web roles, MapReduce, cloud programming model, and last one we have SaaS, software as a service. Now, what is data features and databases? So, program libraries, it is an effort to design the virtual machine image. So, using program libraries, we can design the virtual machine image. Then, blobs and drives, blobs for Azure and S3 for the Amazon. So we are using simple service storage for the Amazon, and in Azure cloud we are using the blobs. It is a unstructured data. Compute instance as a Azure drives and the elastic block store for the Amazon. So we are using EBS storage or EBS store for the Amazon, while in Azure we are using a compute instance. This is a similar to shared file system such as a Lustre used in TeraGrid. Then DPFS, Google File System, that is MapReduce, then HDFS, Hadoop, and Cosmos, right, with compute data affinity optimized for the data processing, designed for efficient execution of data-intensive application. SQL and relational database, both Amazon and Azure clouds offer relational database. Azure and Amazon, the database is installed on a separate virtual independent from your job worker roles in Azure. This implement SQL as a service. Tables and NoSQL non-relational database, emphasizing distribution and scalability. Big tables in Google, simple database in Amazon, Azure table for Azure cloud. And what type of queuing services are used? Both Amazon and Azure offer similar scalability, robust queuing services that is used to communicate between the components of an application. Then traditional features which are common to the grid and cloud. So first one is a workflow. What type of workflow is in the cloud and in the grid? Then what type of data transport? How the data is transported in cloud and in the grid? Then security. So here we are studying what? Programming and runtime support. So workers and web roles already. Then MapReduce for the Hadoop. So here we will go now. Programming and runtime support. So facilitate parallel programming and provides runtime support of important functions in today's grid and cloud. So workers and web roles. Azure provides non-trivial functionality. Workers' roles are basic schedulable processes and are automatically launched. Explicit scheduling is unnecessary in cloud for individual worker roles and for the gang scheduling, supported transparently in a MapReduce. So what is MapReduce? It supports dynamic execution, strong fault tolerance, and easy to use high-level interface. The major open source commercial MapReduce implements are Hadoop, writes with execution possible with or without virtual machine. Then cloud programming model. The GAE and Microsoft America environment represent programming models. Both are applied to the cloud. Iterative MapReduce is an interesting programming model that offers portability between cloud, HPC, and cluster environment. Then software service environment that provides many useful tools to develop cloud application over the large data set. So programming support of Google App Engine. So here we can find Google Cloud Platform and major building blocks. The blocks shown in large clusters of a low-cost server. So here we can find MapReduce job is there. So this is your node. Then Linux. Then scheduler slave. Then here it is a GFS chunk server, big table server, and user. So user will interact. User want to do any application. So application on the node. So Google Cloud. This is your Google Cloud infrastructure. It consists of scheduler, then GFS master, then different types of node. Now what node will consist of? It's a master and slave. So node consists of a single node consists of the big table server, MapReduce job, scheduler slave, GFS chunk server, and Linux. So this is a app engine. So these are schedulers are there for scheduling the application. So this is a GFS master server, and this is the GFS chunk server. Programming support of Google App Engine. Google has hundreds of data centers and has installed more than 460,000 servers worldwide. Google App Engine works as a software as a service. This is more a web interface for development environment that offers one-stop facility for design, development, and deployment of Java and Python-based applications, Java and Python. Google offers the same reliability, availability, and scalability as per the Google own application. Interface is a software programming based comprehensive programming platform irrespective of the size, whether size is small or large. Signature features are there in which templates, export, excellent monitoring, and management console is available. So this is a you'll find Google App Engine, program environment App Engine. So what is here? This is the admin console. So here we are having Python or Java application. So here will be a block store in Google App Engine. Then Google corporate apps, docs, site maps, so Google data interacting using the APIs. Then this will be a data store which consists of memcache, then tunnel servers, internet, your file, or for the security purpose. Google Apps secure data connection using HDC, then secure intranet, and URL fetch, user, mail, images, and Chrome. So this is a Python or Java application. The GWT Google Web Toolkit is available for Java web application development. Python is often used with frameworks such as Django and CherryPy, but Google also supplies a built-in web app Python environment. A data store is a NoSQL data management system for the entities that can be at most 1 MB in size and are labeled by the set of schema-less probabilities. Java offers Java Data Objects, that is a JDO, and Java Persistence API interface implemented by the open source data nucleus access platform, while Python has a SQL-like query language called as GQL. Google added the block store, which is suitable for large file and its size limit to 2 GB. The Google HTC secure data connection can tunnel to the internet and link your intranet to the external Google App Engine application. The URL fetch operation provides the ability for application to fetch resource and communicate with other hosts over the internet using HTTP and HTTPS requests. Google corporate facilities include map, sites, groups, calendar, docs, and YouTube, amongst others. This supports the Google Data API, which can be used inside the Google App Engine. Google App Engine provides the ability to manipulate image data using a dedicated image service, which can resize, rotate, flip, crop, and enhance the image. Then Windows Azure Platform as a Service. Enterprise level on-demand capacity builder. Fabric of cycles and storage available on request for the cost. You have to use Azure API to work with the infrastructure offered by the Microsoft. Significant features: web role, worker role is there, block storage is there, tables and drive storage is available. Then Amazon, we are having the EC2 instance. So Amazon EC2 is one large complex web service. EC2 provide an API for stating computing instances with any of the operating system support. It can facilitate computation through Amazon Machine Image, that is your AMI, for various other models. Signature features: S3, Cloud Management Console, MapReduce Cloud, Amazon Machine Image are the some features of Amazon. Excellent distribution, load balancing, and cloud monitoring tools are available. So programming on Amazon AWS and Microsoft Azure. So image type, private AMI, then public AMI and paid QAMIs. Image created by you, which are private by default, you can grant access to other users to launch your private image. Public AMI, images created by the user and released to AWS community. So anyone can launch instance based on them and use them at any way they like. AWS lists all public images at the following site. Specify the public AMI. And paid QAMI, you can create image covering specific function that can be launched by anyone willing to pay you as per each hour of usage on the top of Amazon charges. Then use of EC2 services in the AWS platform. It is standard instance are well suited for most applications. Micro instance provide a small number of consistent CPU resource and allow you to burst CPU capacity when additional cycles are available. They are well suited for low throughput application and websites that consume significant compute cycle periodically. High memory instances offer large memory size for high throughput application, including database and memory caching application. High CPU instance have the proportionality more CPU resource than the memory and are well suited for compute intensive application. Clusters compute instance provide proportionally high CPU resource with increased network performance and are well suited for high performance computing applications and other demanding network bound applications. They use 10 gigabytes Ethernet interconnection. Then we are having the GFS, that is Google File System, to organize and manipulate use file and to allow application developer the research and development resource they require. Then assumptions regarding to the environment. Community hardware, which is inexpensive. Then component failure is norms rather than the exception. And then TB of space, terabytes of space must support TB of space for this environment.